find the molar mass of an unknown gas that has a mass of 5 grams, is collected in a 1,000 milliliter flask, pressure of 980 torr, and the temperatures in Celsius. Now, the first thing that I did was I just wrote down all the equations. If you have the equations or you memorize the equations, that's awesome. Just think about which one you're going to use with this problem. And it's asking for molar mass, and it gave you grams. So that means you're not going to use, let's cross out some, we're not going to use this one because this has moles in it, doesn't have molar mass. This one has molar mass. This one has molar mass, but it's only used for density, so we're not going to use this one. And then this one down here, again, doesn't have molar mass. So we're going to use this equation, okay? That's how I kind of figured it out, was I looked at what was given, molar mass, mass, and then the other things, and then we're going to use that one. Okay, so now we know what equation we're going to use. We need to make sure that everything works with R, because this equation has R, so all the units have to work with R. So we need ATM, liters, Kelvin, and mole. So if you take a look here, we have none of that. So let's convert them all. So 1,000 milliliters. And every time you go from milliliters to liters, you pretty much do the same thing. So we've done this a couple times this chapter. So have it somewhere, that you can reference while you're studying so that it doesn't take you too long to do this part. Because it's basically this. Milliliters are on the top. Milliliters go to the bottom, all right, to cancel out. Liters goes on the top. And there's 1,000 milliliters in 1 liter. So for this, we're just going to divide these two. Now, it's not cross multiplication, right, because there's a multiplication sign here. This is dimensional analysis. So it's 1,000 divided by 1,000, which is going to give us 1. And because of sig figs, it'll have 4 sig figs because of that decimal right there. All right, so we have liters. Torr, 980 point torr. Torr goes on the bottom. This was another one where we had a bunch of conversion factors. This one was 760. We're looking for ATM because ATM's up there. ATM and R. All right, so we have these two. We're going to divide them. So we get 980 divided by 760. It's going to give us 1.29 once we round it with the 3 sig figs. ATM. And last but not least, we have the temperature, right? And this one we just add 273. I'm not going to make this real fancy, but you should write out plus 273 somewhere so you remember. And that's going to give us 423 Kelvin. All right, so now we have all of these units. Now this is as hard as these kind of problems can get because you have to know to convert them and then plug it into the equation. So here's our equation. I already wrote it down. So now I'm going to substitute everything. Actually, I'm not going to substitute yet. I'm going to move millimeters, sorry, not millimeters, molar mass to the top. Because that's what we're looking for, right? So let's do that first. If you want to, you can just plug all the numbers in and then cross multiply and solve. You can totally do that. All right, but I'm going to put molar mass on the top on both sides. All right, they're going to cancel out over here. So now I have molar mass on the top on the left. I'm going to divide by pressure and volume on each side. Pressure and volume are going to cancel out. So now we just have molar mass equals MRT over PV. So now we can just plug it in because we should have all of this stuff from above. Mass is 5 grams. R is all of this. The temperature is 423. And then we have pressure, 1.29 ATM. And volume. Now let's cancel everything out that's the same on the top and the bottom. So we have ATM, we have liters, we have Kelvin, and that's it. Grams per mole. That's what we're looking for. Grams per mole. All right, let's plug this in our calculator and see what we get. Cool. Yeah, I did too. 134.6. Let's talk sig figs. It looks like 3 is the least number of sig figs we have, so I'm going to round it to 135. 135 grams per mole.